makers. In my last video I printed a statue of a full Inmoov. The statue was 300mm high, and at the end of the video I actually compared it to the Inmoov that I've printed previously. That Inmoov I've named Fred, and he's actually version 1. I have got a second one that I was working on for a walking robot. That project appears to have stalled. One of the things I've noticed coming up in the forums is to do with some of the control system. Now, if you follow the Inmoov.fr website, the one hosted by Gael, who actually originally designed the Inmoov robot and did a very good job of it, you will end up having a pair of Arduino Megas in the back of your robot and a lot of ribbon cables. The ribbon cables can be difficult to route on the outside, and it also makes it a little more difficult for disassembly if you need to pull arms off your robot. I opted to go for a different path. There's no right or wrong way of building any robot. There's just the way you want to do it. So with my build, I opted to not go with the Arduinos and instead put a Raspberry Pi 3 in the head, and then use the Adafruit 16-channel I2C motor drivers, servo drivers, to place a few of them placed strategically throughout the body. In this case, this is Inmoov's left arm, and in this one, underneath this cover, I've placed the I2C driver. Now, there's some pros and cons to doing this, like there is for anything. I've run a ribbon cable down to control all the servos. I've also added an extra I2C cable down for a analog input module in the forearm, and then that's all connected via I2C back through the shoulder. And in the shoulder we have the I2C bus and we have power. The I2C and the power come through the hole in the shoulder joint, so all the wires are hidden under covers. I've also got a ribbon cable running down through the middle. Let's see if I can bring that up and show you. I have a ribbon cable going up through the middle of the bicep rotator, and that allows me to use this servo driver to drive this servo as well through a connection up here. So we keep all the wires nice and neat. I did originally put a voltage regulator in here, but while running off the 6-volt battery, it was dropping too much voltage and it actually caused it to break all the biceps, and that's why I have one white one and one black one. I actually snapped one. I think from memory the white one is the new one and the black one was the old one. Another question that comes up regularly is to do with the pots for these joints. So the servo, which is located down here, before you install it you will need to extract the pot off the back. If you don't, you'll break it. There's also a stopper pin that you need to remove from the gears, and that allows them to continuously rotate, which we need for this worm drive through the middle here. The pot you then need to connect or mount on the side here, and then connect with wires extending and back into the servo to where the pot originally was. Before you go too far, connect up your pot like so, but before you connect this worm drive up, test it. Make sure that it's going to turn in the right direction to move the arm in the direction you need it to go. There's been quite a few people who have broken them because the wires were back to front on the pots. It's very easy to get them back to front and mixed up. So it pays to test it with power to make sure it turns in the right direction. So when you power it up with a signal going to it to centre it, as you move the pot, it should try and turn to force it back the other way. If it doesn't, you've got it going the wrong way, and if you hook it up and you tell it to go forward and it goes backwards, it'll just keep going backwards faster because it's going in the wrong direction. So I can't stress this enough. Test it before you hook up that drive, that screw drive. Otherwise you'll end up breaking it. And there's nothing worse than breaking your brand new Inmoov. I have had an undervoltage problem here which caused it to jerk, and these are strong enough to break them. I've already broken one already, and I don't recommend it. It's not a particularly good thing. I'm missing a cover off this. Might have to reprint them. I started welding my parts together. These were initially glued. This is where I first started learning to weld, so some of the welds are pretty bad. I have, with practice, gotten better at this. And these covers clip over quite nicely and hide all the electronics. So yeah, the I2C is good. Now the other downside of using the I2C system with the Adafruit boards, these are a PCA 9685 board. While it simplifies the wiring considerably, I only have the I2C bus and 5 volt for the board plus the main power for the servos. The downside of it is there's not a great deal of support for it in the Inmoov configuration within my robot lab. That is currently being worked on. There is new versions being worked on currently, and hopefully it'll be easier to integrate this type of control setup. I did get this working by actually writing my own Inmoov routines within my robot lab. There is good support inside my robot lab for the Raspberry Pi's I/O connector, and there's good support for the Adafruit Servo driver using the I2C on the Raspberry Pi. I have got one of these boards in each arm. I've got one in the middle of his back, and then I've got a Raspberry Pi hat from Adafruit with the same chip in for inside the head, running all the servos in there. So I'm just going to open this up a little bit more. And get into the servo bed. That's another area that's fun and games. I may have to redo the hand on this. I have some ideas to try and improve on it. This one I tried to set up the sensing on the fingertips, but if you don't get the right anti-static foam that has resistance through it, it doesn't work very well, and I discovered that the hard way. This one is missing a servo. I don't remember pulling that out. Would explain one loose finger though. And these are all a little bit on the tight side. One of the modifications I'm thinking of doing to this is you can get this plastic tubing. It's used in 3D printers, usually between the hot end and the extruder motor on your 3D printer if you have a direct drive. It's a 2mm inside diameter tube with a 3mm outside diameter, and my thought was to run it from down here all the way up and provide a lower resistance. These go through a rotator in this area, in the wrist. So the thought was if I run the tube all the way from here down, it might help keep the tension better and stop it from slackening off. That's one of the biggest areas where we end up these coming slack all the time. I haven't adjusted these for quite some time, and I am going to have to replace that motor, that servo. Now down the front here, you can actually, you might be able to see buried down the bottom is actually where the ribbon cable from up at the controller comes down here, and all the servos are plugged in down here. And these wires here that are not connected to anything are actually for I2C and 5 volt, and that was going to be for an analog input to sense the pressure on these fingers, but since I couldn't get those to work, I haven't terminated that. This other ribbon cable here coming down is actually from all those fingertips. There is actually a 12 channel touch sensor you can get that's I2C as well, and I was thinking of putting that into, and then lining the inside with aluminium foil and each area connected back to make it a little more touch sensitive on the arm, so if someone touched the arms it could pick up on it, and potentially on the back and palm of the hand as well, but I never did get to that point. So that was basically just to show what I'd done with mine. There is still some work being done on the Inmoov robot. Gael has been very busy of recent and hasn't had a great deal of time to work on it. Hopefully he'll get some time in the near future to continue development. There are a number of people working on the legs. Hopefully we'll soon have an Inmoov that actually walks, but I suspect what we're going to see is a fairly large collaboration on that one with multiple people. Some people who can do the mechanical design work, some who can do the programming and control system, and then people with the artistic talent to actually make it look good when it's all finished. But yeah, these are actually very good, and as you can see from this, that's my connection to the rest of the robot to control all 5 fingers, the bicep rotator, and it works reasonably well. So that'll do for this video. I'm planning on doing one on Raspberry Pi in Inmoov's head, so with a bit of luck I'll have that come out reasonably soon. And I'll see you on the next video. Don't forget to click subscribe and like if you like the video. That way you'll be notified when the next one comes out.